All right. Started. This rate, I'm going to have like 3 people in class. I'm going to ask you questions. There's a small enough sample here that the people who didn't show up say anything. The final exam is currently scheduled for December 22nd at 7 p.m. And that's kind of like getting the last row of the plane in the middle seat sort of selection. I'm going to talk to the associate head of ops about this, but I am allowed to do the final in class. And I'm thinking of doing it the last day of class instead of doing it on Friday, December 22nd, before essentially the winter break here. I mean, I'm looking at this and saying, even if I get the exams back and I give them to the people who will scan them for me, I'm willing to bet you I won't see them until January. So that's one of the options. So I'm going to just do a quick poll here because it's small enough that I can ask you all. That would be one option. The second option is to allow you to skip the final and just do the capstone, and that would be your entire 45%. Other option is give the option of taking an exam on the last Thursday, whatever it is, of classes, or to take the final on Friday, December 22nd at 7 p.m. So those are the 3 options. I guess the 4th option is screw you. You be there at 7 o'clock on December 22nd. So I'll just ask for a poll of hands. What I really want to stack ranked voting, but so he's already raised his hand. He doesn't even know what I'm going to say first. All right, so if you just want to stick with the 22nd of December at 7 p.m., speak now. 1, 2, 3, 4. Everybody's local, aren't you? Right, no travel involved. Okay, so that's fair. How many would prefer to take it the last day of class? 1, 2. I don't know. I'd have to go look it up. It's a Thursday in like December, early December, like the 9th or the 10th or the 8th or the 6th or something. You actually have a phone in front of you. You could probably go look it up faster. It's actually on the syllabus too. That's why I'm being very hand wavy. Interesting. How many people prefer to have the capstone option? Capstone's okay. Oh, geez. So this is kind of like split decision sort of thing. And how many would you prefer to have the option of doing it on the last Thursday versus Friday, December 22nd at 7 p.m.? Okay. So, I mean, I suppose I could do this like a proposal. Just send out proposals and you can start voting for them, right? Well, that poll wasn't super telling. Like it was 4 people voted for last Thursday of class, 3 people who voted for, or 3 or 4 people who voted for, December 22nd. I think there were 3 people who said that they thought that capstone was a good idea, and 2 people who said, give us the option. Or no, yeah, that was right, give us the option. All right, well, I'll have to take this under consideration then. There's no clear consensus here. Thank you for your participation, our qualmetrics survey. I just wanted to do something informal and casual. I was hoping there would be, sort of a general consensus. Yeah, let's just get this thing over with, and that way I can use the time to study for my other finals, or no, I want as much time as I can possibly to ignore this stuff while I'm working on my other finals so I can cram it all into my head 2 days after my next to last final. I don't know. It's not like the final is weighted super heavy in this course. Well, having said that, let's just get into class. logistics, which I guess that is kind of a logistics thing. Not much to say here. Only thing notable here is that Jonas had a conflict with his usual office hours, and so he has he's moved to tomorrow. Lots of things going on. Design Project 2 code submission is due on Thursday at 5. The code does have to compile. I want to set the bar super low here, but you need to at least make sure it compiles. Question? I'm sorry? How could they even screw that up? I didn't even have an option to say don't anonymize. I hate Canvas. All right. Okay. Well, my apologies then for something I. Okay. You've got me. I'm left totally speechless that they actually exposed the names of the people. Like, weird. I'm sure that it would somehow be my fault because it was some non-obvious button someplace that didn't get clicked this time that got clicked last time. All right. Well, not much we can do now. Next week, Capstone Project 2 report is due. Design Project 3 due. Your self-assessment for Klempman Chapter 5, which. All right. Due right next Tuesday. And then peer review implementation report is due on Tuesday, November 2nd. Thursday, November 2nd, not Tuesday, November 2nd. It's easy to do when there's like 3 lines to put in there, but then I start like having 6 of these in there and deleting 3 and moving them around, and I screw it up. At any rate, I didn't give you a failure today. You're not going to fail on your capstone. So we're not even going to talk about that option. It's going to be about the capstone because people seem to be suddenly realizing, oh my gosh, this is real, and I have to actually think about this. And it's very interesting for me to watch and to see how the removal of training wheels is causing people a lot of grief. It doesn't mean it applies to everybody in this room, but there are enough people who are really uncomfortable with the idea of having an open-ended project. My observation here is that almost everything you do from here on out is going to be an open-ended project, particularly if you are working in the cutting edge of technology. Maybe you just want to be a barista at Starbucks, in which case then you don't care. Your capstone isn't going to make any difference. What are my learning goals for the capstone project? It's the same thing I told you all along, which is I'm actually trying to teach you to go without the training wheels, but to identify a problem, to determine a potential solution to that problem, to look at what other people have done relative to that problem, to design and plan something related to that problem. In theory, you would be designing and planning an algorithm or a project, or of course, some of you are going to say, no, it's time to get right there into the code editor and start writing code. Okay, if your approach is that you would rather just simply write code, go for it. There's always an implementation. Your implementations are going to be garbage, odds are. Like, Georgia Tech has a program called Educational Technology, where you get, in one term, get to design an entire project from beginning to end. And in some ways, I've modeled this a little bit after that. This is a lot lighter weight. I know of 2 people who have completed that class and actually received published papers out of that class. I'm not one of them. So it happens, but it's not the norm. The norm is that what you're going to do is you're going to experience this process of going through tackling a problem, coming up with a potential solution, exploring the solution space, and then reflecting on what you're going to do better next time. It's going to be easier to do it this time. Next time, you're going to be actually working at a job where they really are going to be constantly watching you and assessing you and watching you make mistakes. Some of this is to give you the skills and the right outlook to solve those kinds of problems, to tackle them. So that self-reflection and critical thinking is really one of my key takeaways from this. I want you to be able to look at your own work and give yourself useful critique. It's not always easy to do. It's really easy to just simply pat yourself on the back and go, hey, look, I got a really good grade out of that class, even though I did completely shitty work. But you know, at some level, I didn't do my best work there. I'm not driving this. You are. Collaboration and teamwork are something that I've tried to encourage here. You can formally work with other people in a team. You can informally communicate with people. You can share ideas, code. I don't care. The goal is to solve the problems and to understand how to go about solving those problems and to learn more about how you think about problems and how you like to approach problems. One of the important elements of doing good design is having different perspectives on the problem. One of the things you will see happen a lot in tech companies is that the tech people hire people just like them. And that lack of diversity in thinking is deadly in a project. Anybody in here taking machine learning? You know what ensemble learning is, right? You can take a bunch of crappy learners, put them together, and come up with something that is a better learner than any of the individual crappy learners. That's the lesson there. Diversity and weighting things differently, looking at things from a different perspective, coming up with different analyses actually leads to a stronger outcome. Communication skills. I already heard people kind of sigh about the fact that they're going to have to put together some sort of a video at the end. And it's like, yep, you have to be able to promote your own work. The people I know who are the most successful in the world are often not the smartest. They're almost always really good at self-promotion. They're almost always really good at communicating what they've done and why it matters. Yeah, okay, there's lots of ethics consideration. I've spent too much time talking to chat. Every single time I suggest anything, it's like I get this whole monologue about ethics. It's like, okay, I totally get it. We start dealing with other people's data, we have to think about the ramifications of that. If you're building a messaging app, you have to think about, okay, how am I going to protect my users from each other? Fine. Continuous learning and adaptability is really a key takeaway here. I keep going over pretty much the same kinds of topics and approaching them from different angles and different directions. I've used Kleppmann and Petrov sort of bake off against each other, and I'm finding that actually very effective. They have different outlooks. Some people have already mentioned Kleppmann's videos. They're very good. There are a lot of really good videos on distributed systems out there, and they come at these things from different perspectives. And you need to do the same thing. I had somebody ask before class about, well, you know, what would happen if I did this? And I said, well, what's the problem you're trying to solve? And then I basically worked through so they had picked a tool. I've got a solution, and now I need to go find a problem to which I can apply this solution. And I said, well, okay, I think that you find a problem with that solution. Talked through it, and I gave some suggestions of what might create a situation in which that's useful. And I mean, I've kind of thrown this one out before, and that is, under what circumstances would you use a leaderless Paxos implementation? Think about it. I'm not going to give you an answer. And then, of course, there's the whole feedback and iteration. I have given you guys this whole feedback cycle. I definitely get the sense that people kind of lose the trail towards the end. Yeah, just get this done so I can move on. And I suspect that that's probably a combination of things. I can tell you that in the real world, projects don't start and end in a 11-week cycle. They go from anywhere from 3 weeks to 6 or 8 weeks, modern sprint stuff. And then you do it all over again, and you just keep doing it. And each time you end up revising and reviewing and looking at what you accomplished and what you're trying to accomplish moving forward. And it doesn't matter whether you're using agile development or waterfall methods or some weirdo hybrid that you decided that's going to work for your startup company. You always have to do that. In the real world, companies do it all the time. They build a product, they try to sell it. It doesn't sell very well. They try to listen to their customer. They don't listen to their customers. Usually the feedback is that people stop buying their product. Anybody you ever played a game? You ever picked up a game, you start playing it, and you go, this sucks, and you throw it away? No? Every game you've ever played you liked? One person has played a game and said, this sucks, and stopped playing it, right? If you're the game developer, how do you make your game better? I'm not going to answer that one either then. You guys can sit there and think about it. That's the point. The Capstone project is your project. It's not mine. I'm not going to give you the answers here. There is no right answer. There's no one Capstone project. There's no one distributed systems problem that you should be looking at here. When you walk in and you use the DS Labs, it's like, okay, somebody's already packaged some things up for you, so you can walk out patting yourself on the back because, gosh, look, I was able to bludgeon that Java code into kind of working good enough to pass the class. They're hard problems, no question about it. This is harder. And some of it is harder because it has to be real. All right, so you need to identify a project that interests you. That's part of the driver here. You aren't always going to get to choose projects that interest you, but in this case, I strongly encourage you to do that. At some point, maybe it interests you because you can stop panicking because you have to get something done. You can work solo or you can do it with a team. I've left that very open-ended because some people hate teams, some people like teams. And I work with somebody who basically never leaves her apartment because she hates people. She likes me for some reason. I don't know why. So like, I'll come to campus, we'll have coffee, but I don't like people, okay? And that's not uncommon in the tech business. I've known lots of people who are really good developers, and what you really want to do is stick them in the corner and dust them off occasionally because they can crank out really good, high-quality code. Maybe that's what you want to do. Okay, you can do that in your Capstone. It's cool. If you're trying to build something more ambitious, you may find that working in a team is beneficial. Then again, you may find that you end up with a team of people who you thought were really cool and turn out to be idiots. Or maybe you're the idiot, and you're the one who's getting carried along. I don't know. Different strategies there for different folks. You need to decide what you want to learn from this project. The rubric is focused about your ability to learn. I'm not here because I want to see your code. I'm not here because I want to see your 5-minute video. Although they will make really cool additions on YouTube, right? Maybe I can make a montage of them. No, I'm not going to do that. So the rubric is focused around design, self-reflection, communications, interactions, problem identification, scoping, and evaluation. Notice what's not on that list? I don't really care about your code. Code isn't going to matter. The code's not what matters. I know you've just spent 3.5 years being told that your ability to write good code is what matters. Yeah, well, at this point, if you're not writing decent enough code to continue on, I'm not going to bludgeon you into it. What's going to set you apart is the ability to solve problems. Lots of people can write code. Only some people can actually tackle problems, and especially difficult problems like these distributed. What makes a good project? Well, relevance and impact is a big one. Why does this matter? You could write the world's best, I don't know, something, widget generator, whatever your widget is. And if nobody uses widgets, nobody cares. How much originality and creativity are you showing in your project? That's actually an interesting one. You know, are you just simply taking the easiest thing and like throwing it out there? Okay, away with that, but it's not really going to be that impressive to you or to me. What is your depth of understanding? I'd actually rather you take a narrow topic and go deep on it and show me that you have a lot of understanding about it and why it matters than if you try to tackle some really shallow thing. I can't even come up with good examples here, but I think the one I came up with was, suppose you decided you came in your proposal was, I'm going to build a primary backup replication service. I'd be like, okay, is that it? Oh no, I'll use a view server. So you're going to do DS Labs Project 3. Not exactly super interesting. What are you going to do to make it interesting? Well, I'm going to model it, and I'm going to put invariants in it. I'm going to use a model checker to prove that my model of the implementation actually satisfies my invariants. Okay, well now I'm getting a little more interested. Now it's at least a little bit of originality there. You get the idea, or not. Good project is iterative. Why do I have you like looking at things every week? Because I want you to keep thinking about the problem and going over it and saying, let's move this thing along. You'll notice that you're spending more time up front thinking about this than you are implementing it. Because the implementation isn't the emphasis here. It's the process of designing your solution. Implementation is a mechanism for testing your design. Self-reflection, effective communications, collaboration, team dynamics. Oh, gee, look, I got self-reflection there again. Growth. Are you improving? I'm hoping that people's capstone projects and their designs for the capstone projects are actually better than the designs that they've done for the design project. Some of that might just simply be actually getting graded on it for something other than just submission. Are you open to feedback? How many of you have actually looked at the peer feedback? How many of you gave good peer feedback? When you look at your peer feedback, would you say it was good or useful? Could you do better? Right? Strive to do better. That's improvement. Someday, maybe a couple years from now, you're going to find that you're going to have junior newbies out of university, and you're going to be trying to explain to them what they're doing wrong and how to get better. So think of this as advanced practice for that. It will happen. And again, notice what isn't listed. Code doesn't really matter. If your design is solid, your code could be mediocre and I won't care. If your code is really good, but it doesn't actually have any design behind it, how am I going to know? It's not like I'm going to sit down and run hundreds of different programs or even dozens of different programs. There isn't enough time for that. But I can read those design documents and get a pretty good sense of what you've accomplished. So I'll start off with a list of generic project ideas, since I'm sure that some of you, how many of you actually already have a project idea that you're pursuing, Capstone? I would say that's about 15 to 20% of the class. Great, so this is timely then. The generic list. Well, let's see, let's pick some distributed systems problems and list them on the board. G, a distributed file system, a distributed task scheduler, distributed key value store, distributed consensus algorithm comparison, i.e. Paxos versus Raft versus Bootstrap replication versus PMMC versus, I don't know, what other algorithm? Blockchain. practical Byzantine fault tolerance. Do a comparison of those, I suppose. Distributed caching system, more like an object cache or an object store. It kind of starts to sound a little bit like a key value store in some ways, but maybe the emphasis is a little bit different. Caching would tend to be a read mostly workload, so you could make different assumptions about it. Distributed lock manager. We didn't spend a huge amount of time talking about locking in transactions. It is covered in the text. But you can build a lock manager that does distributed locking in order to build distributed transaction systems. Not an uncommon approach to this. Distributed stream processing system. I mean, that's not about water quality in freshwater mountain sources. Right? We've got messages coming in or events that we have to process in a rapid fire fashion, and we have to sort them and handle them. Distributed machine learning. Ooh, now you got into the sexy stuff, right? Ooh, distributed machine. Yeah. There's a lot of people who are interested in doing machine learning. And yet, if you actually look at the people who work for the machine learning folks, they always have distributed systems because the problems become large enough you can't actually solve them on a single node. I have a picture somewhere of my original PhD supervisor standing in a machine room next to a 70,000 core distributed system that they used. I think it was certainly for something very, very large like that, graph processing. 70,000 cores. Blockchain. You could invent the next Algorand. Do simulations. I've talked about modeling tools and invariance and space state exploration. You look at that approach. Great. So those are the generic ones. So let's give you some advanced generic ones. Geo-replicated databases. So now we have a different set of assumptions about what we're doing with that database. And you'll notice that I moved from key value store to database kind of subtly there. Let's say you decide you're going to take MySQL and you're going to geo-replicate it. People have already done it, right? But distributed tracing and monitoring. Turns out this is a really hard problem. Everybody's collecting all their little log files, and how do you merge them together so you can actually come up with an ordering of events in a distributed system? There are techniques for doing this. I didn't talk about them much this term. I did go through cuts last term and a mechanism by which messages through the system that get reflected back, you can reason about order, or at least an ordering of events. Because when we try to merge logs, what we're trying to do is come up with a linearization of events. That is, we have a potential order of the events, not necessarily the one that actually happened in our system. Serverless architectures would include things, well, primarily things like lambdas, functions as a service. I have another slide in greater detail on this in a minute. Distributed graph processing, edge computing. Anybody know what an edge computing is? A couple people. All right, so everybody has a device now. A lot of the functionality is now implemented near your device, literally in the mobile phone network. As we move into augmented and virtual reality, very slowly, but we're moving there, more and more of that processing ends up getting moved out close to your device. Why? Latency. Latency becomes a real problem. We have to have very high responsiveness. And the longer it takes for us to send messages back and forth between your device and whatever's doing the actual processing, it makes it harder and it gets a lot more expensive. These are cutting edge issues. The people I know who are working on 6G, are looking at this stuff. And They containerize things, they move them out towards individual nodes, sometimes on the cell towers themselves or sometimes within the metropolitan area network. So this functionality is being moved very close because they're very latency dependent. Distributed security. We haven't talked a lot about security, but security is a huge issue as we start putting ourselves on the network because, frankly, you can't trust anybody on the network. Distributed real-time collaboration tools. How does Google Docs actually work? I don't know. If I'm sitting there trying to, I don't know, maybe we have a distributed Dolly, right? So we can all sit there and co-author weird ephemeral pictures in words and real time. What about quantum computing? How are we going to distribute computing in quantum computers? Statistical inference spread out. How does quantum networking affect? So, kind of edgy stuff, and it's sort of weird, and I don't expect anybody's going to pick up more than one or two of these ideas. You could pick a research project and you could try to reproduce it. I've known quite a few people who try to do this. They actually pick up some paper and they say, I want to try and see if I can reproduce the results these folks came up with. It's a big issue in scientific literature in general, not so much in computer science. I have a pretty deep system now of replication studies. But in medicine, it's a huge issue. Like people sit down and they try to reproduce the results of a paper and they find they can't reproduce them. In physics, they've got this room temperature superconductor that I think it was Koreans came up with, and the jury's still out on that one. Actually, it's very interesting. There are people who are saying, yeah, actually, I can see theoretically why this might actually work, and then other people are trying to reproduce it, and they're getting different results. And it turns out that some of it is because there are complex issues in the production of this material that may have introduced impurities that might lead to seeing the behavior that the original researchers have. So reproducibility is important. It's useful. You want more researchy things. Distributed systems for decentralized finance. Yeah, I'm in this for the cryptocurrency, baby. You could be the next, what is that guy who's on trial right now? Yeah, Sam Bankman. You, too, could actually be there talking to a judge and a jury, hoping that they won't put you away for the rest of your life because you stole, billions of dollars from people. Decentralized exchanges, lending platforms, they're all distributed systems, aren't they? They're kind of very edgy, researchy things, but maybe that's what your interest is. Really cool. There are these two different systems using MRDTs and CRDTs, which are two different kinds of data structures that allow for eventually consistent systems. And interesting question would be, could you build a hybrid system that was better because it supported both of them? Maybe it supports MRDTs in cases where that's appropriate and it uses CRDTs in the other cases, but it still guarantees eventual. This is much more researchy. This is kind of hand-wavy stuff. Distributed systems in healthcare are really interesting because this is where you get really into the strong security concerns. And how do we share patient data? How do you do telemedicine? What do you do about real-time data monitoring and alerting? Okay, the idea. So let's get a little more concrete. And these are in the slides, so you can actually click on them and it'll take you to various websites and papers and whatnot. Distributed databases and NewSQL systems. Example systems here would include Google Spanner, CockroachDB, and TitaniumDB. And the key paper that inspired these is this paper called by Michael Stonebreaker, who was Margot Seltzer's PhD advisor. One size fits all is an idea whose time has come and gone. And his argument is that there's no one size fits all database. that you actually end up building databases that are customized to the particular problem you're trying to solve. And it gives us very different database systems. And these are distributed databases. They're all a variation of distributed databases. Distributed machine learning. Paper there is this one large-scale distributed deep networks. This gives rise to TensorFlow, which you may or may not have heard of, but TensorFlow is a commonly used machine learning framework. And it's most well known because, of course, it makes it easy to use GPUs for training models. And Horovod, which is itself a framework that's built on top of TensorFlow and other frameworks. I'm probably saying it wrong. Here we go. This is, I didn't even put a title on this one. This is stream processing, distributed stream processing. That leads us to Kafka, which in turn leads to Apache Kafka, which is the Apache organization's implementation of the Kafka protocol. This is heavily used in industry today. Still alive, very alive. Apache Flink and Apache Storm, all of which are stream message processing systems with different characteristics. Take one of those and say, I want to get involved in the project. I'm going to go look at what the project is doing and find some bugs to fix in it and like steep myself in that. It's a different experience, but it still would lead to my outcome, my goal, which is learning. Learn an awful lot more about how these actually work. Are you going to do a lot of deep introspective work on them? Probably not. You're going to learn a lot, and that's my goal. Serverless architectures, functions as a service. There's a lot of different papers on this. I picked this one, A Berkeley View on Serverless Computing, because it's pretty heavily cited and has had a lot of influence. Amazon, AWS Lambdas, Microsoft, Azure Functions, and Google Cloud Functions are all serverless architecture systems. This is a big thing. This is what people do. They, instead of building even containers, which are too heavy, they build chunks of code, and they farm that chunk of code into an environment, might be a container, where it just runs. And it might run for a few hundred milliseconds. Generally, it'll run for like a minute or two, perform some operation that you need, and then it goes away. And the idea behind this is a way of better utilizing resources. So there's a lot of ephemeral state. Anything persistent persists outside the function. So it does some work, and it returns a result, effectively what it's modeled after. Distributed tracing and monitoring example, Dapper, which is in turn the basis of Zipkin and Jaeger. We're interested in distributed tracing and monitoring, a couple of well-known uses. Distributed ledger and blockchain. Of course, I can't get away without citing the Bitcoin paper. And then I'd mentioned this and somebody else dug the paper up. Yes, so there's this paper. I actually saw it presented in, I think it was 2017 in Shanghai. That's the conference I was going to go to this week that I didn't go to. Currently, Koblenz, Germany. Called the Symposium on Operating Systems Principles. I saw Algorand presented in, like I said, I'm pretty sure it was Shanghai in 2017. And that's about a consensus-based, a quorum-based consensus protocol for Byzantine environments that actually requires, actually allows up to, I think it's around 2/3 Byzantine actors. So it actually maintains consistency in a Byzantine environment where you're outvoted 2-1, which is pretty cool. And they went off and did a startup company. So there's a company built around this stuff now. I couldn't find the paper on the land title registry. There are several papers on land title registries, but I couldn't find the one that I was originally looking for. But this, so I pointed off at another interesting, fairly recent article that discusses it. So the idea is that you can use a blockchain for recording land titles. Land titles are a big deal because that is in essence how the government keeps track of who owns a piece of land. If those are easily fungible, in other words, somebody can just go in and tamper with it, you can lose your ownership of land through fraudulent means. So that's a Byzantine environment. Pretty interesting projects going on. Examples of this include Ethereum and Hyperledger Fabric, but neither of those are land title registries, but you can probably build a land title registry over either one of them. Ethereum has been in the news recently because they changed their way of computing consensus. They went from what was called proof of work to proof of stake. So way to think about that is it becomes an oligarchy, right? The more you own, the more you get to vote. Distributed systems and edge computing. The key paper here was the emergence of edge computing. I'm pretty sure this was the paper that Satya wrote. Satya is 70s. He's got to be Lamport's age, and still is actively working and teaching at Carnegie Mellon University. A really, really interesting guy. Been around a long time. I met him years ago. Well known in the industry as well and in the field, and he's still very active. He's working on edge now, and then he started working on fog, like beyond the edge where it kind of gets fuzzy. On AWS has a couple of different edge products, so I gave you links to those. Distributed graph processing. Does anybody know what a graph is? Okay, so a couple people know what graphs are. Turns out that as graphs get larger and larger, they get harder and harder to work with because we can't fit them into memory. And we've been trying to do things with our graphs because we want to compute the correct solution to the traveling salesman problem. Actually, Facebook has a really big graph. Almost any social networking site has a very large graph that they manipulate. And it turns out that it's not just social media that needs graphs, but lots of problems are well structured as graphs. My own research, I end up looking at things as being graphs and using graph structuring, in a graph database for storing things. What am I interested in are relationships. I'm interested in relationships in terms of things that you store, but also what you did with them, and what you were doing. And it just gets bigger and bigger and bigger. I don't know, I did a dump of my files and loaded the metadata from my files, and I have about 6 million files. So, and I don't consider that to be a really big graph. 6 million vertices are large, but I probably have, well, when I'm done, I'll probably have 600 million edges. That starts to get to be in the kind of small but interesting graph size. Some of the graphs end up being billions and billions of edges and nodes. And graphs are very useful. Apache Giraffe and Neo4j. Neo4j is a graph database. Apache Giraffe is a graph processing. There's lots of other systems as well, Pregel, and remember them all. Distributed multi-agent was an interesting one. I was like, what are these? I'm trying to come up with ideas to throw out here. There you go. There's a paper on, these are like multiple actors interacting with each other, doing nefarious things, no doubt. Here was a cool one, distributed virtual reality in gaming. And the best paper I could find was actually done, it was broken into 2 pieces, so I've given you links to both pieces. This paper was the basis for both the 2 most popular game engines right now, which are Unity and Unreal. Anybody ever worked with Unity or Unreal? How many of you play games using Unity or Unreal? Come on, right? Pretty much everybody, right? So, very interesting stuff. This is a highly sensitive latency environment. So, you get latency in there, and the gaming experience suddenly becomes bad. I mean, have you ever been playing a game and suddenly it just lags? And you just start going, oh, this is so wonderful. I'm so happy I get a nice break here. Yeah, right. You're sitting there swearing at the computer going, ooh. And then you come back and you're dead. Distributed file systems, I decided I would give you an example of this. Of all the topics here, I know probably more about this than anything else. And I'd be hard pushed to come up with very many people who know more about these than I do. Just because I've been working on them off and on for years. So there was the network file system that was the 1980s. The Andrew file system was the 1980s. Two different completely different schools of thought on how to do distributed file systems. NFS did no shared state. AFS did strong shared state. And today they still both exist. They are still both in use. NFS version 4 has strong shared state. So I guess in some ways AFS kind of won, and people use them. I worked on the successor to AFS, which was the EDFS, the Common Internet File System, which is how Microsoft branded their SMB protocol. Actually, they have an RFC, and I pointed to the RFC there, so you know that this is a Common Internet File System. That's how share files with Windows computers. So Linux has Samba, which implements CIFS. I pointed to Frangipani because Frangipani is, as far as I know, the very first distributed file system that used Paxos. Literally, they were looking for a consensus algorithm, and Lamport said, hey, I have one for you. And they read it, and they said, this is exactly what we needed. And they used Paxos to implement their distributed file system. So you could pick that up, and you could say, hey, I'm going to play around with Frangipani or something. I don't know. If you're looking for something more au courant, there's the Interplanetary File System, IPFS, which is an active project that is a completely decentralized serverless file storage mechanism. Kind of like blockchain meets file storage. Distributed hash tables are, in essence, a variation on a distributed key value store. Not a huge amount of difference here, but they're very interesting. I've mentioned Cord a couple of times. Cord has this really cool algorithm for allowing you to add and remove nodes from the pool of servers. And it also allows you to move specific keys. This is the interesting thing. Like, even if you do the Design Project 3, where you're balancing shards, they don't balance keys, they only balance shards. You're going to actually balance the individual keys, but now you need to have a routing table because you have some way of figuring out where that individual key is currently located. And the reason that you want to pay the price of balancing the keys is because keys can go hot. You have a particular key that's getting fetched all the time. So I talked about web cache, right? So you're going to build a distributed web cache. And what you'll end up doing is building something that's very much like Cord. You're going to end up building some sort of key value store that allows you to move your keys around so that when something is hot and everybody's downloading the same object, you can spread that load across multiple servers evenly, so you don't end up with bottlenecks. And Pastry and Tapestry are a couple of other examples that I dug up that I'd never heard of before until applied together. So the challenge for you at this point, now I've given you like way more ideas than probably wanted. Probably sitting there going, well, the primary backup replication server sound really attractive right now. Pick a project. Decide what you're going to focus on. What is your primary objective here? What are you really trying to learn about here? You want, pick a team. Say, I'm my own team. Me, myself, and I. That's all I need. Or you can say, I need to work with some other people. The primary evaluation of your capstone project is, how well did you motivate the project? Well, I had to finish this so I could get a good grade. Well, that's not a very good motivation for me. And I guess maybe I should have said that. How well do you motivate me to be interested in your project? Because if you can't motivate me to be interested in your project, I'm going to be going, sucks. That's like playing that video game for 5 minutes and you go, this is terrible. Don't beat that video game. I want to see you demonstrate your ability to design a solution. Because that was the whole emphasis that I've laid out here, is design. I've been talking through these problems, and the reason I keep talking through these problems is because understanding the problem is a key aspect of building a good solution. Okay, so now you got to design, convince me that it's interesting, and now you're going to evaluate it. How good was my design? How well does it answer the question that I initially posed? What was the problem I was trying to solve? How good a job did I do in solving that? You got to convince me that this isn't just a piece of fluff. Even though we all know it's probably going to be a piece of fluff, but make it a little less fluffy. How's that? Put some chocolate chips in it. And finally, I want to see how good you are at communicating your results effectively. You could hire somebody to do most of this, but eventually, at some point, you're going to have to put a video together. That's hard to fake. It's getting easier, right? I don't know if you saw the recent news. One of the news agencies said that 90% of the footage they're getting from the Israeli-Hamas conflict, fake. Or possibly fake. Like, yeah. So, go ahead, fake it if you want. You'll still learn something doing it, and that's really my only objective here, right? You notice what's not on this list? Your code. I don't care about your code. I will look at it. I will make sure that it's there. I might even try to build it if I have whatever random tools you decided to write it in. Oh, I decided to write my entire program in brainfuck. Okay, and you're sitting there going, there's a language? How many of you knew that this is a real legit language? Yeah, because of course, you're sitting around bored and you're reading Wikipedia. What else do you do? You look at stupid stuff like that. There's another one called Malibol, which is like the hardest language to write in. And like hello world is this hideous, horrible, nightmarish piece of code. Yeah, well, if you send that to me, I'm not going to compile it. But you can show it to me in your video. You can say, here, this is the program that I wrote. Somebody asked me if they could write in Go. And I was like, I haven't answered them yet, but I'm like, of course you can write in Go. You can do it in Rust. You can do it in C. If you want to do it in Python, I don't care. Code that you use, the language that you use, doesn't matter. If you want to write it in VAX assembly language, let me know. Because I have an organization that you might want to work for that uses VAX assembly language. You know what a VAX is? Right, it's a dead computer. And yet somebody's still maintaining VAX assembly code. It's not quite as old as COBOL. You know the scariest thing about COBOL? There's more COBOL code still running today than there is in any other language. And I bet nobody in this room has written a single line of COBOL. Well, anybody in here written COBOL before? Yeah, right. Sort of. It's a weird-ass language. I haven't done it in, I don't know. I was like 18 or 19 when I wrote some COBOL code. Not a bad one. This is a little bit different than the normal conversation. Not that different in that I'm the one doing the talking. You guys are sitting, they're kind of going, huh? Whole deer in the headlights thing. Pretty cool. Do you have any questions? Are you feeling deeply motivated by this yet? I mean, the goal here is to be fun, right? It's not easy. But it is supposed to be fun, and it is supposed to be something that you can use to help hone your own skills. You're going to leave this class, you're going to leave this university, and you're going to go end up writing COBOL code someplace. And while you're writing COBOL code, trying to figure out how to fit the forms on the field, the screen is just a form, right? And you define where everything is in the form and how long it is, and it's horrible. It's absolutely just like horrible, but from the 1960s, what would you expect? Probably a little too much acid. Enough. No. Grace Hopper. I don't know if you've ever heard of her, but she was one of the people who was instrumental in getting COBOL accepted. And COBOL was a compromise. There were other alternative languages, but COBOL was. So at any rate, when you're writing that COBOL code and trying to figure out how to fit those forms into the fields and blah, 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 aiming about fault tolerance instead. That's all I got for today. I think the weather is starting to turn colder. I think they said it's supposed to be tonight. So we're going to get into iffier weather times, places. So my fallback plan, the university gives us a lot of leeway here. My fallback plan is to sit in front of my computer at home and stream this and record it, which would be very different than standing here and streaming it and recording it. The only difference is that you can basically like fill out in your own code or watch it while you're on a bus ride from here to hell to someplace warmer. That's the same thing. Well, no, not technically. Right? Dante's 9th level of hell was really cold. Right? I think it was the 8th level that was hot, wasn't it? 7th or something? I don't know. He had a very vivid imagination. So that would be a good project name, Dante. On the 9 levels of distributed systems. All right. Then I'll see you on Thursday, and we'll be back to the normal routine, whatever the next chapter is. I can't even remember at the moment. Chapter 5? 7? I don't remember. It's on the syllabus. It is on the syllabus. I have the questions are all done for it, so those will open up on Thursday. Much quieter than usual. Smaller, too. And don't forget, next Tuesday is Halloween. I don't know why you need to not forget it, but maybe I'll dress up for Halloween. I could come as a fat old computer geek. You'd never recognize me. Exactly. Down the candy and let the little boy go. I'm going to just stop streaming.